What do you mean? How basic? I think the command was just color, right? Color, space, and then do the hashtag. Or all right, good morning. We're back continuing to work on the adding some sort of physics-based motion to the hairstyles in the game. And we made pretty good progress. When was that? Yesterday. So now I've got this script, which I attach to the correct bone right here. I have these two scripts right here that say go find the bone that's a child of this one called chain 1L and chain 1R and create a chain of moving of physics bones, basically, or sort of like slightly physics-ish bones. When we run this, now we see we get a little debug showing my script exists, and if we rotate things, we get some motion. It's still a little questionable. Yeah. One challenge is that I'm not allowing any compression at all. So what happens is, like, when you move toward the direction, it really has to like get out of the way to stay the same length. So I may want to include the ability to slide this a little bit in different directions. But we'll get to that. And actually, before I get properly started, I better get myself situated. I'll be right back. Okay, so as I was saying, we're getting somewhere with this, and there's a bunch of numbers that I can tweak to make this better. This is kind of the worst case here, is when it like compresses in on itself. You get a little bit of sort of jittery motion. But I think the thing I want to get going first is rotation limits. Oh, hey, Big Gamey, good morning. We're back on the hair today. Got our base script going pretty good. So I think the first step is I want to add rotation limits to this. Also, now that I've seen the scale of things, I'm going to change some of my debug drawing here a little bit. So let's go find this script. Okay. Now real quick, let's change our drawing here to be much smaller. Okay. And then we want to start implementing this right here, max angle. And I'm probably going to have to do a little bit of debug visualization on this to make sure it's working properly. Let's go like this. Let's hide the hair test, and instead let's look at my little debug test here, which the scale of this might be a little, it's quite different than the actual hair, but that's okay. Alright, so I think what we want to do now is let's get a thing going here where we can draw the max angle. That shouldn't be too difficult. Should be something like here. Okay, so when right here we're drawing the nodes as they point. I might want to change this instead to draw the rest position for each node. I think that would be helpful. Yeah. So let's see. I do that right here. Well, by doing this, right? Yeah. So I think, let me test that. So if I say, let's see. Yeah, this isn't gonna change. It's actually just the angle. So let's try this. Quaternion rest angle is gonna be the node.node transform.parent right? Yeah. Dot rotation times the node.rest root rotation. Okay. And then based on that, I should be able to get this, which is just this. Okay. Let's try doing this. Node.node transform.position and then node.node transform.position plus restdir and draw that as well. And I think think, let's see, not gonna see much here at first. All these lines are gonna be essentially like overlapping. But if I crank this up, there we go. So you can see this white line now is saying this is where I wish I was pointing. Here's where I'm actually pointing based on the offset, which right now I have to just like give it a lot of gravity for that to really do anything. We should be able to see this better if I make this into like more of a straight chain. If we get rid of this rotation we were doing on these. Okay. So it's just a straight line. It's going to kind of bend a little bit as I increase gravity's impact on it. Yeah, so you can see each one is like, okay, I wish I was pointing this way. And see then this next one, like I wish I was pointing that way. And this one's like I wish I was pointing that way. So that's the basis. That's the center line for our max angle constraint thing we want to add, where we want to say don't let this thing go beyond some cone. We're going to be able to set that, I guess, per node here. Okay, so now we've got that. So let's just do a quick thing. It's like at this position, node transform dot position, and the direction is rester. Yeah. And then I guess it'd be nice if we had a tangent to give this right out of the gate, but I guess maybe we can just calculate one or something. Okay, so we have a position and we have a direction. So what we want to do let's see. So we do something like this, and then we can say if vector 3 dot dot dir and up is like greater than 0.9 or something, and we'll say up is actually, you know, right or something. Doesn't really matter. We just need a vector that's different enough from those two. Then that gets us our normal, I guess, or I guess this is probably actually a tangent, is vector 3 dot cross of dir and up. And let's doubly normalize that just to be safe. Okay. So then, oh, and I guess we want to know the angle. Okay. And so here, that would be node dot max angle. Okay, so then what we can do is we can build a rotation. Yeah, we're gonna build a vector that is our, I don't know, what we would call this, edge dir. And that's going to be a quaternion formed from an angle and an axis. The angle is angle, and the axis is our tangent. And then if we just multiply that by, we take dir and rotate it by that much, we get taking the center and we're figuring out how to rotate it by the angle like that, and then now we can spin that around dir and we should be able to get kind of like a cone. So for this to work, then we can do something like for int I equals 0, I is less than, let's say, 16, I plus plus. we could say vector 3e is equal to and we'll do this. This is probably not the cheapest way to do this, but I don't particularly care. Angle axis. So we want an angle here, so this is going to be float I divided by float. Well, I guess we'll just say we're hard coding the numbers, so 15.0 f. Okay. Now this needs to be in degrees. And the axis is dir. We take our base edge dir, and that gets us that. And then we can be like debug, draw a line from position to position plus E. I guess we might want to explicitly say what color we want. Okay. And we could do something like this where we're like yeah, so we could say this vector endpoint is just position plus E. Then we can say here that our last endpoint is endpoint, so we're remembering it. So this actually just goes from pause to endpoint. And then we could say if I is greater than 0, so we've set this once, we could draw a line from last endpoint to endpoint. Okay, that's gonna have one segment missing, but that's okay. Yeah. I guess we could, yeah, let's not worry about it. This is just for debug. Okay, let's see if that code, oh wait, we're gonna want to pass in a color, so our cone is gonna be cyan. Why not? It's very colorful. Okay, so after that compiles, we should be able to run this and see some cones. Look at that. And they're, wait, how is that not missing a segment? Am I like double drawing this? Oh no, because it's going to the previous one, so it works out. Okay, cool. I wrote that code better than I thought. Now these are all, I think, at 45 degrees right now. And so what this means is if we crank this up, you know, like we would have to hit like, you know, that much movement before we would be constraining these. But that's what we want. Cool. Okay, now we're going to be able to apply this cone constraint right here. I'm thinking right now to keep things simple. We have some data we wish we could set, right, per spring, or per node. The max angle and the spring values, the frequency and the damping, are the main ones. Yeah, and we're probably going to end up adding in some more easing to this thing too as well, with length, to allow it to stretch a little bit and compress a little bit. But we're not going to worry about that yet. So one thing I was thinking is we could just have a so after awake, the chain has been built, right? So we could just add a thing that's like, well, you could give it some fields, like a list. Yeah, how do I want to do this? This script, you could just drop on an object, but we're also going to be creating it at runtime. Yeah, and actually, I already kind of know. Yeah, okay, this is what I want. I want a little bit of an external data structure for this. So we're going to, where does this thing live? Dynamic hair chain right here. So we're gonna create another thing. We're gonna create a script called dynamic hair chain data. Beautiful. This is gonna be a scriptable object. So let's go find an example of one of those. That's not one. What do I have? Level set or something? No. No. What have I got that's already a scriptable object in this game? Oh, well, I made one with my prop list. We could use that. This is just because I always have to go look up how to do this. This line right here. Okay. So this is this, and then this is a scriptable object. Okay. And then this is gonna have some data on it, such as the I guess a lot of this stuff actually. Gonna consider moving all this over to this, and that hopefully will make sense in a second. So this is just gonna have a getter. Okay, gravity scale, same thing. Public float gravity scale with a getter. Okay. Oops, this needs a return statement up here. Okay. Not public volatile. Public float. Okay. Public int distance constraint iterations. Oops. No, no, no. Don't do that. There we go. Okay. And then what's this? Inertia factor. Okay. And then we'll add some more fields here for this, and then we've got this guy, which we might as well make like this. And can I do this thing? Yeah, let's slide this up to the top. Right there. Okay. Alright, then what we want is like, we have like a system.serializable public struct node data. No, node parameters, right? Node parameter. And here you've got just like public float max angle, public float spring frequency, public float spring damper. It's actually damping ratio. Okay, and then we're gonna have a serialized private node parameter array, which is node parameters. And we'll be able to get at that like this. Okay. Something like this. Then what we can do is we can say a dynamic hair chain actually is just going to be given a data to look at. Okay, so this, then we're going to change some stuff here. Like this. And of course this whole thing's going to explode if you don't give it a data ref, and I should put some protections in there for that and stuff, but, you know, whatever. Data ref gravity scale. Constraint iterations. Inertia factor. Main axis. And another one here. This whole thing replaces that. Okay. And here. And then the other thing we can do then now is when we are building our chain, we need to know which layer we're on here. So this is going to be a 0. Go find build chain. Okay. And we say int depth. Okay. So here, what we can do is say if data ref dot node parameters does not equal null, and data ref dot node parameters dot length is greater than depth, then we can pull this data from there. So we say max angle is data ref dot node parameters depth dot max angle, etc. Frequency. Okay, and the damping is equal to data ref dot node parameters depth dot damper. I call it damping in one spot and damper in another spot. And then if that didn't exist, let's just give it some defaults. Okay. And then we got to pass in here depth plus 1. Okay. All right, so now go back here. Hopefully it's going to compile. It's probably going to compile. Okay, we should probably fix this real quick. Here, if data ref equals null, return. Okay. Okay. So now we need to make one. We're going to end up making these for oh yeah, poses. That's where I had a bunch of data. Yeah. And the set environments. Anyway, now we go like this. New folder. This is going to be called hair dynamic hair. And in here, let's make one. So we're gonna, oh, oops, I didn't name that properly, did I? Yeah. Hair data, Gymnast 2, dynamic hair data. Okay. So first let's make a test one that we'll use on our little test chain here. Okay, so if I say create, Gymnast 2 dynamic hair data, and this is hair underscore test. Okay, so we know our bone axis is -1. Gravity scale for this one, just to make sure we're seeing data, is, you know, I don't know, 1. And let's give it some nodes. So that first one, let's say the max angle, let's say 15 degrees. Let's make this kind of weak springs. So like 5, 1, 15, 5, 1, 15, 5, 1, 15, 5, 1. Okay. So now, if I go here, and I set this as the data, and we run this. Okay, we have a weaker piece of hair, and we have 15 degrees set as our max. So now I can get it to, see, break out of that right now because I'm not applying that constraint. I'm just drawing it, but it means I've got the data. And this is going to be very sluggish. System. Okay, so now let's get that max angle constraint working. So that's going to be right here. I think I can do this pretty simple because I have already yeah, we know the position of where we want to be, and we also want to know the direction of the rest angle in world space. And this is going to be n.node transform. No. It's going to be, it's going to be n.node transform direction. Wait a minute. Oh, okay, yeah, that was the end. That was the end point there. Yeah. So it's going to be n.node transform direction data ref bone main axis. Okay, so that should give us our center line. Okay. And we know where, which is actually going to be the same thing as just the normalized vector of rest point world minus our position. Do I need that? Do I need the actual? I do. Let's do this. Vector 3. What do we call this? Root position is equal to n.node transform position. Root point world. We're calling everything something world here, so we know we're in world space. Okay. So now we need to know the current this is what is this? This is two end point. And we say n dot endpoint endpoint position minus root point world. Okay, so now we know our point here. We have a line saying this is the direction of ideal no rotation. That's what's rester world. Now we have a thing called to endpoint, which is going to wherever that thing currently is. So now we have these two here. We want to know the angle between these two. And I'm going to do this the cheesy simple way, which is we're going to get the rotation to end, which is going to be a quaternion dot from to rotation. We say we want to go from rest dir world to the to endpoint vector. That's going to return us what rotation is required to get that. And then that's cool because we can say rot axis, we can say rot degrees, and then we can say rot to end dot to angle axis. And we can get out the rot degrees, and we can get out the rotate axis. Okay, and then we can just say if rot degrees is greater than n dot max angle constraint. So how do we do that? Well, the good news is we should be able to create, we can basically just say, what is it? To end point is now going to be, and right now to end point has the correct length. So we need to maintain that. So to end point is going to be a quaternion dot angle axis. Okay, we're going to rotate n dot max angle around that same axis we got a second ago. So before it was rotated about some axis too many degrees. Now we're going to say, okay, well, let's go back and just rotate the correct number of degrees around that same axis. So that's now max angle around that same axis. And then times rest der world. Now the only problem here is that this is going to give us back a unit vector. So we got to do times to end point dot magnitude. Okay. And based on that, we should be able to say n dot world point is equal to root point world plus 2 endpoint. Okay. And we're not going to worry about velocity too much because it's going to get recalculated. Alright, let's see if that works. I don't know. Okay. Still have a null reference exception going on somewhere? Or is that from before? Oh, no, we still have something here. Data ref is not null, but shouldn't chain be null? How are we getting into that code? There we go. We have a chain, but everything on it is null. What the heck? How does that happen? Yeah, that's still the case. That's weird. How can that be? Is this, let's see. What if I get rid of this component? Okay, so everything's clean again. Dynamic hair chain, add it. Not freaking out. Give it some data. Not freaking out. Okay, not gonna worry about that too much yet. Okay, now we should see our cones. Ooh, look at that. It will not go outside of that cone. Let's look at it like from the top. Alright. And then let's do some swirly motion. Okay. And even if I rotate this pretty rapidly, it can stay inside there, because this thing, you're just not allowed to go outside that. Cool. Oh, hello, the Osiro. Thanks for the follow. We are currently trying to make some somewhat physically based dynamic bones that we can put on hair here for my weird gymnastics game I'm working on. Okay, so we've got that constraint working fairly well, I think. So let's see how much we can use that to help our actual hair test. So let's turn that on. Another game on Twitter, pretty cool. Hey, thanks a lot. Yeah, appreciate it. Appreciate you dropping by as well. It was fun to chat with people while I'm working on it. Alright, so here's our test hair. And we need to create a data script for these. Now how many chains have we got here? We have 1, 2, 3, 4 nodes. Is it gonna add a 5th one because this thing exists? Probably. Or not, because it doesn't have a child. I think it'll be okay. So I think it's gonna be 1, 2, 3, 4 nodes. So let's go here. Let's make this one. This is gonna be hair female 7. Or we did it this way, F hair 7. So let's name it the same thing. Okay, so this thing oh, that's a little annoying, isn't it? Yeah, I'm gonna want to be able to. I kind of want to share a lot of this data, except say make 2 chains, right? Right, so it would be nice if this script could be given more than 1 or something. Okay. We're about to refactor that part anyway, so let's leave that alone for a second. Let's just do this on the left pigtail. Okay. If we leave the rest of these the same, and we just go now to... I mean, I guess we could just... I don't know. Yeah, I don't like that. I don't like that. Okay, let's just test it for now. So we're only going to have 1, and it's going to be this. So this should put some math here on. Okay. And my debug drawing is huge compared to the scale here. And what did we want? We wanted to try... Where does this first one... This first one is pointing like that. We may need to adjust this a little bit some more. But if I go here and I say, hey, this first node, max angle is like 5 degrees. And this one's like 15, and this one's like 30, and this one's like 45 or something. Okay, now why does it want to look at this from like straight on? This part is a little strange to me that how much it wants to like sit down. And I guess let's see. What else we got going on here? Okay, so if this is gonna be hard to see with all this debug on here, isn't it? Guess we can really see the jitter though. If she goes upside down, what happens? Okay, it does not like that. We gotta figure out what's causing that. Yeah. Okay, well, that's the next step. I gotta use the restroom. I'll be back in a second. Okay, so we're definitely seeing some behavior there that was pretty different than my test case. And probably the first thing I need to look at here is like why is the hair like falling like that? Like you would think that it would just point straight down. I think this is really hard to see. Why is this really that small? Like what kind of distances are we talking about here? Seems really small. I don't know, I guess that's what? No, that's about right? It's 1.6 like meters up or something. Okay. See, when you look at it like this, like why would it be like sort of like being yanked inward? That makes no sense. So we gotta figure this out. Can I change these numbers live? I can't change these down here. I could change this. Okay, if I set gravity to 0. Okay, gravity at 0, it looks okay, right? And if we move it, we get really slow reaction. That's because the springs are really weak right now. That makes sense. Let's see how it doesn't fall down straight. Well, no, it shouldn't right now, sorry. But if I turn this on, am I doing gravity in the right, like, space or something weird? Okay, that makes sense, because we're constrained now by the angle limits. And that's why it's probably so hard for it to resolve when we're, like, upside down, because we're just hitting the angle constraints at every turn here. Maybe I do need to constrain the velocity when I apply that cone, that max angle constraint. Okay, so that looks okay, but why when this... Let's go back. How come... Like, what is that? Why is that not pointing straight down? Alright, it's definitely not pointing straight down. Like this one. What? Shouldn't it point straight down? So they never quite do. Let's test something. I don't think it's related to these max angle constraints. So we set this to like, you know, 90 or something, which is gonna draw really weird. Yeah, just a bunch of discs. Let's see, look at that. This first constraint says no, I have to be pointing out this way, which is what we want. Then this next one is like, I can point almost any direction I want. Why would it point? More than straight down. And let's see if we get rid of this. Yeah, see, look at this. Let's go like this. So the resting thing is here, but it's ending up over here. And then this one, yeah. Does this have something to do with like order of operations? Maybe, do we have an extra chain here at the end? We might. We got some magenta down there. Okay, so what's happening there? In theory, we have a spring between a point right here. Let's see, let's go look at this right here. So that thing is sitting right there, but the white line of its like center is right here. For some reason, it's getting pulled off to the left. And this one even more so, and this one even more so. What is that? Yeah, these are the... Oh, wait a minute. So is this just because... Okay. So I think what's happening here is... You got this first one. It's like, I wish I was pointing off this way. But the actual thing is all the way down here, and it's actually breaking this constraint a little bit, but I understand why that's happening. It's because that's an order of operations thing. Then this one says, I want to be... Okay, fine. If the root one was pointing this way, my rest rotation for that is pointing off in this direction. This long white line here. And then math says, nope, you're pointing here. But then what happens is they say, oh, we're pointing here. Well, the next one wanted to be curled a little bit and wanted to be pointing this way. And then math pulls it back the other way. And the last one says, I still wanted to be curled a little bit, and it's getting pulled off that way. Okay, so that explains a little bit to me why it wouldn't go straight down. And then where we yank on it, what's the magenta lines again? That's the live positions. This doesn't seem right. But we're probably causing some real trouble with this much gravity. Interesting. Okay, now if we visualize what we're doing here, and we turn sideways, what do we get? Okay. Go upside down, it should be like, yeah. Still coming out of there, out of that little spot where the hair is bunched up, kind of in the general direction it was authored, and then it's like, okay, but I need to flop down this other way. Well, that's not too bad. Okay, what about... That's weird. What was this? I've done some strange rotations here, I guess. Okay. What about movement? Alright, so we were having trouble before where it was freaking out when I had lots of cone constraints going on. This is just like slow motion hair, but otherwise not bad. Okay. So let's try changing these numbers a little bit. Let's look at this again. I wonder if I should try to truly fix the problem that was happening when you have like multiple constraints going on at once here. Oh yeah, I guess if this angle, like I should kind of look at these actual bones here and see what the angles are like. They're weird too, they're not just on one axis, which is kind of stupid, but whatever. See, this one's like 40, it's like 40 degrees. This one's like 13, this one's like 8-ish. Yeah, so like if chain 2 here doesn't have at least 40 degrees of like freedom, then that's gonna break. So that makes sense. I'm like fighting the rig with the constraint. Alright. So let's say this is like, you know, like 60 degrees, and then these ones can be like 60, 60. Let's make the springs a little stronger. Let's make them twice as responsive. Okay. I still don't quite know what to do with this. I gotta have gravity. I guess maybe that's... yeah. Let's look at this though. So let's assume I can improve that for a second. It's cool. It's relatively stable. Now what if we're like moving? Okay. And like extremely rotating around. Not bad. It's probably still too floppy, right? Probably what I'd actually want to do is have this be quite strong, right? And then like this one is like a little weaker. Something like that. And then maybe what we would do is like slightly overdamp up here. And then down here just like slightly underdamp it or something. Let's see what that looks like. Yeah, I gotta think about when you have this like curl built into the rest pose of it, it's causing problems with gravity because gravity pulls this first link down, and these other ones, gravity's not as strong, so it's able to counteract gravity and like still curve. Doesn't really make sense. Oh yeah? Maybe we'll have to figure out a faster way to do that. All right. Okay, this is getting somewhere. Right? Like we can tune this, but this is starting to look more like what we want. So what do we do about this gravity problem? The way these things are authored, I have to have this like curl in the thing. I mean, I guess I could go back and I mean, if I could like rig them as like straight out or whatever. That would be one thing. But I can't really do that.
Mine is 6 because I use those for the comma things.
Mm-hmm. Oof.
Oh god.
I'll come help you later.
Oh, I did.
You wanna be on my screen? That's my son. All right, I'll finish up here. All right, so I'm pretty happy with this, except for this. Now, I suppose, you know, in a case like this, this first node here, like, the more I strengthen it, the less this is going to happen. Right now it's only slightly happening, and it's because of this curl on the second parts here. I mean, is it like... I mean, one thing I could do is I could not take that rest curl into account. How would I do that? I would say these things wish they were pointing straight, you know, as opposed to saying they wish they were bent how they were authored. I believe that could even be something I mark per node. But if I look at this, so here, what I'm doing is right here, I'm calculating where each node wishes it would be based on the authored original rotation. If I didn't do that, instead I said what? If this was the identity, let's see what this does. This is probably going to make this hair try to point straight out to the right. Which is probably not exactly what we want either. Right. Okay, wait, we're losing everything here because we need this node to at least point in the direction it originally did. Yeah, so it's not that simple. Let me think about this. I mean, just as a quick, like, crappy test, we could say n dot node transform dot parent equals what? This dot transform question mark. Then we do n dot root. Otherwise we do that. And this should mean that the first node gets to point in the direction it wants to, and all the other ones might still... Oh, I think I'm doing this in world space, so that's probably still going to be wrong. No, okay, yeah. So see, now it's like the first one gets its authored direction, and then after that, everything else wants to point straight. Now we see that our gravity isn't doing much. But even if I crank this up, it's going to point more or less straight down. So yeah, because I thought this is local rotation. So what we could do though then is that means we could add a thing to this, which is like public float. What would we call this? It's almost like how much does this maintain its original curl strength. And that's something that we could grab on a per node basis. Curl strength. Okay. And then what we would do here instead, right here, is we would do quaternion.lerp from the identity to its original rotation by the amount curl strength. Okay. Yeah. So then what we could do is we could say that like this first one needs to be 1. The rest of these can be like, they could be fading down over the distance of it. So this one would be like, I don't know, 0.5, and then this one would be like 0.15 or something like that. Okay, so I got that backwards. Wait, if I set all these to 1, we should have the previous behavior, shouldn't we? No. What have I done? What have I done? Lerp from identity to, yeah, okay. With these being 1s, oh wait a minute. Duh. I'm not setting that in the build. So when we build the chain, we need to set this right here. Node data.curl strength equals data ref.node parameters depth.curl strength. And what do we want the default to be? 0.75. Okay. So I should have had these numbers okay. So we want the first node to be strong all around. And then this can be, yeah, like 0.5, this can be like 0.15, and this can be 0. Okay. Now they're so strong, they're overcoming gravity. No, I don't have any gravity. Put gravity back in the mix. Okay. So now see this one still having that much strength, I guess, is what's... Yeah, but that's really helping a lot. Okay, cool. These are numbers I can definitely tweak. And we're getting pretty good motion out of this now. Right? What happens if we go upside down? That's pretty strong pigtail. Probably a little bit overly strength. And that's a little weird, that wobble there. But you kind of get the idea here, which is good. And let's try moving it. Alright. Cool. Probably try turning off this debug drawing so I could visualize it even better. But this is definitely getting somewhere. I might, you know, in this case I might make this hair a little stronger, I suppose. But this is cool. I like this. Yeah, look at that. Look at that. Cool. Now, I mean, this is kind of gonna be annoying that it's gonna like clip into the geometry. So I may need to add a little simplified collider system where I can put spheres on some transforms and say like stay out, which ought to be relatively simple. This is looking pretty good. Yeah, and I may even want to change the angle on this in the rig to better represent the like tangent. Almost like I want the bones to represent the tangent of the hair, not the actual like author direction. This is good. I've got a nice base here. I can definitely tune this. You know? Okay, so I try at least figuring out how am I going to solve the problem when I have multiple chains. Before I maybe stop for today, because my son is actually learning to program as well in Smile Basic 4 on the Nintendo Switch. And it's Saturday. I should help him out and not spend too much time working on this game. So the way this is ultimately going to work is that this hair, we're going to add a slot to it in the avatar system. That slot is going to be able to run some code to turn on all these scripts on the extra bones, which is why I made this into a scriptable object, because ultimately what we're going to do is we're going to make the slot reference this scriptable object and call the, like, you know, okay, so maybe that's what it is. This is just supposed to be the data for a chain. I mean, this is probably like the only hairstyle in the game where we have two chains we want to have identical data, but I could just break this up slightly. Because my plan is that I'm actually going to add onto the scriptable object. Down here I would actually add a function. Like this. And we would actually go like find the bones and add the scripts and the data, basically. Because I'll be able to call this function when the avatar is created. And so then it will essentially have the job of putting this script onto the correct root bone. So what I need though is I need a little more information for that to work. I need to know the actual root bone, and then I need to know the chain bone. So what we could do is we could say yeah, and there's a question of, do I want to build this in a way where I can also just plop these scripts on things and make them work? I don't know. Alright, well, since I don't have this plan fully worked out, so I can't just like immediately move into like hooking it up, I'm gonna call this a successful session today, and then on Monday I can pick up, and by then I'll have had a couple of days to think about how I want to structure it. Probably what I'm gonna do is keep it simple. I'm gonna add another little piece of data that's just like a hair builder that can take this like root chain data, because some of this I might actually be able to share between like this and like say a ponytail on one of the other hairs. Yeah, especially if I author this out to more nodes than any of them have. Anyway, okay, cool. Yeah, so I'm going to pick this up on Monday, and the goal will on Monday be to get this actually integrated data-wise in, so that when you load up the game with one of these hairs, oh, well, I guess with this hair, first of all, I just got to get this hair working. Or if you come into the game with this hair, it's got dynamics. And then if that works, then I have to go and add bones to all the different hairs that need it and do the export process. So turning into a little bit of a sequence here, but that's the way it goes. Alright, I will be back on Monday. As is often the case in the weekends, I might make a little progress off stream, just in the little pockets of time throughout the day, but I'll catch everything up, and yeah, man, have a good weekend. Same to you, BitGamey. Thanks for hanging out and chatting. Have a good weekend. See everyone back on Monday.